If you want hybrid retrieval without stitching together half the stack yourself, Azure AI Search gives you vectors, BM25, and semantic ranking in one Python workflow. This is the workflow you'll know how to run when we're done, which fuses keyword and vector signals, then re-ranks the results semantically. I'm Professor Pi, teaching Search and IR with simple Python. Search is messy in real systems. Keyword search finds literal matches fast. Vector search finds similar meanings but can miss exact facts. Hybrid retrieval blends both. Azure AI Search packages keyword scoring, vector nearest neighbors, and a semantic reranker into one managed service. That avoids wiring separate vector stores, keyword indices, and an external reranker. For small to medium corpora, this reduces engineering risk and speeds experimentation. Intuitively, hybrid retrieval gives you a candidate set from both worlds, then uses a smarter model to pick the best final order. Think of a librarian who first grabs shelves that mention your words, then checks books that read the same way as your question, then uses a critic to pick the top paragraph. It boosts relevance when users use short queries or mixed phrasing. We will build a tiny example that mirrors that flow. We make an index that stores text and a 4-dimensional embedding vector. We upload 3 simple documents. Then we search by keyword, add vectors, run a hybrid query, and finally enable a semantic reranker to reorder candidates. That sequence keeps each step small and shows the added value at each stage. Now we will verify connectivity and list what indexes are available. This snippet connects to Azure AI Search and confirms access by listing available indexes. It reads the endpoint and admin key from environment variables, then wraps the key with AzureKeyCredential for secure client construction. The SearchIndexClient is created with the endpoint and credential, establishing an authenticated handle to index management APIs. It calls list indexes to fetch metadata and collects the names into the variable names for a quick sanity check. The OK variable verifies that configuration values resolved and the client was instantiated. The printed values confirm connectivity and show how many indexes you can manage, proving the service is reachable. Next, we will create an index that supports both text and vectors via the REST API. This example creates a hybrid-ready Azure AI Search index using the REST API. It sets the index URL with the API version, then defines a body containing string fields for ID and content, plus a 4D content vector for embeddings. The vector search section configures an HNSW algorithm and a profile named v1, which the content vector field references. A request.putCall sends the definition with the admin API key header to create or update the index. The response object R contains the HTTP status code, which indicates success on 200 or 201. The printed values confirm the index was provisioned and show the total fields now available. Now we will upload 3 documents and run a baseline keyword search to see BM25 behavior. This code uploads 3 small documents and executes a BM25 keyword search in Azure AI Search. It initializes a SearchClient with the same endpoint and credential, targeting the hybrid index created earlier. The variable docs holds simple text content that is indexed for full text search. The upload documents call pushes these records into the index, so they are immediately queryable. It then runs search with the text lunar power, returning the top matches scored by BM25 relevance. The result list is materialized for easy access, and the first item's ID and score are shown. The printed values verify keyword retrieval is working and reveal the current best hit. Next, we will attach small embeddings and ask the service to mix vector similarity with keyword relevance. This snippet enriches the same documents with small embeddings and performs a hybrid vector plus BM25 search in Azure AI Search. It first uses merge or upload documents to attach a 4-dimensional content vector to each document, enabling vector search. The vectorized query VQ defines a query vector, a K cutoff, and targets the content vector field. The search call provides both the text query and vectors parameter, allowing the service to blend keyword relevance and nearest neighbor similarity. Increasing K tends to improve recall but can add latency. Decreasing K speeds queries but may miss candidates. The printed top ID and score confirm that hybrid retrieval is active and influencing ranking. Finally, we will add a semantic configuration and let the semantic ranker re-rank the hybrid candidates. This example enables the Azure AI Search semantic ranker and re-ranks hybrid candidates. It augments the existing index definition by adding a semantic configuration named sem that prioritizes the content field, using a requests.put call against the same index URL. With configuration in place, search is invoked using query type set to semantic and semantic configuration name set to SEM, while still supplying the same vector query for hybrid recall. The variable S retrieves the re-ranker score when present, falling back to the base score otherwise. Higher re-ranker scores typically indicate better semantic matches. The printed ID and re-rank score demonstrate improved ordering powered by the semantic model. Mapping this toy flow to a real project is straightforward. Replace the 3 documents with your FAQ or product catalog. Increase the embedding dimension and dataset size. Add monitoring for latency and a small evaluation set to compare BM25, hybrid, and re-ranked results. Recap what it is: a single workflow that combines BM25 keyword scores, vector similarity, and a semantic re-ranker in Azure AI Search. When to use it: when you need robust relevance for short or ambiguous queries and want a managed stack. One caveat: the semantic re-ranker adds cost and latency, so test whether re-ranking measurably improves your user experience. Next step: tune BM25 parameters K1 and B while keeping hybrid vectors active to see how keyword sensitivity changes which candidates reach the re-ranker. If practical, hands-on IR helps you. Subscribe and watch the IR videos.